Today we will talk about probability. First, let's start with some definition. An event is a possible result from an experiment like rolling a die and getting a 6. Probability of an event A is the count of times event A occurs divided by the total number of events that occur, meaning that it will measure the size of the event that you are interested in relative to the size of the set of possible outcomes. And to calculate the probability of one event or another occurs, we can sum the two probabilities as the formulas show up below, and thus apply only if A and B are disjoint, which means it cannot happen at the same time. To calculate the probability of one event and another occurs, we can multiply the two probabilities. It only applies if A and B are independent, which means that the probability of A occurring does not change the probability of B occurring. And the probability of an event not occurring is the one minus the probability that it does occur. And the sample space is the set of all possible outcomes in a trial or experiment. For some notions, we have the symbol for A or B, A and B, and A is a subset of B. And to the probability we need to fulfill a set of basic conditions that it has to be larger than 0. The probability of all sample space must be 1, and if A and B are disjoint, probability of A and B will equal to probability of A plus probability of B. Random variables is not random or a variable. It's a mapping function that maps elements of a sample space to a value. And one example of random variable x would be the count of number of heads when tossing a coin twice. For this, x will have a mapping as the picture below. And conditional probability is if two events A and B are not independent, then the probability of A occurring will depend on whether or not B has occurred, which means probability of A given B will equal to probability of A and B divided by probability of B, and probability of A and B will be equal to probability of A given B multiplied by probability of B.